Okay, welcome back to the flipped class. Today we're going to be talking about integers and also the coordinate plane. And just to make this flipped class even more awesome, I've got a Jayhawk dunking a basketball. How do you like that? In fact, happiest place on earth? I don't think so, Disneyland. We're talking about Allen Fieldhouse, home of KU basketball. But, having said that, let's move on. Okay, I want to talk about positive numbers and negative numbers. Positive numbers are usually written without a positive symbol, but you could write a positive symbol, and they are greater than 0. So if it was really hot outside, and it was 80 degrees, I guess that's not really hot, but warm, okay, nice day, you could say that is plus 80 degrees, or just 80 degrees. And when you see these, you see both of these numbers, you know that they are positive. They are above 0. They would be on the right of 0 if this was a number line and not a thermometer. But if you have a very a very cold day, and let's say the wind chill was negative 20 degrees, that is because negative numbers are less than 0, and they are always written with the negative sign. So if you see something that looks like this, it means it's negative 20 degrees, which means 0 degrees, very, very cold. This is 20 degrees colder than that. Give you a couple quick examples. If you're watching a football game, you see the football field. The quarterback throws downfield for a gain of 15 yards. You might see something like this as the graphic. Next play, they hand it off to the running back, but he's stuffed, so he loses 3 yards. He goes back 3 yards from where he began, basically from 0. You might see minus 3 yards. Okay? If you spend $75, you are down $75, negative 75. If it's 10 feet below sea level, if it's below, it's less than negative 10. Okay, I've got a number line here. Obviously, we see 0. Okay? 0 is its own, what we call opposite, okay? But the rest of the integers, and you see it says negative integers, positive integers. Integers are the set of all whole numbers and their opposites. So not decimals, not fractions, but whole numbers and their opposite. Opposites are the same distance from 0, but on different sides of 0. The opposite of 2 is negative 2, because if you start at 0, you go 1, 2, to the right, and you end up at 2. If you go 1, 2 spaces to the left of 0, you end up at negative 2. Plus 7, what's the opposite? Well, the opposite of that would be negative 7. Okay, if I asked you to graph the integer negative 4, where would you find it? Well, you'd go back from 0, 1, 2, 3, 4. Of course, you'd also see it's labeled, of course. But what if I asked you to also graph the opposite of negative 4? 1, 2, 3, 4 on the right of 0, and you'd end up at 4. Okay? Let's talk about absolute value. The absolute value of an integer is its distance from 0 on a number line. The symbol for absolute value looks like this, and you'd have the number in between. Okay, so if I said, what is the absolute value of 2, if I asked you for that, you would see that 2 is 1, 2, so the absolute value is 2. It's 2 integers away from 0, 2 units away from 0 on the number line. Now, and this is important, okay, I'm going to even switch colors here. If I asked you for the absolute value of negative 5, you'd start at negative 5. Oops, start at negative 5. 1, 2, 3, 4, 5. It's 5 units away. Absolute value is not negative. You wouldn't say, oh, it's negative 5 away from 0. No, it's just 5 units away from 0. So the absolute value of negative 5 is 5. Because it's still 5 units away from 0, it's just 5 to the left. Okay, let's talk about comparing integers. If I asked you to compare greater than, less than, or equal to negative 4 and 2, you would see that negative 4 is on the left of the number line, 2 is on the right. So yes, if you're just looking at the whole number 4, of course 4 is bigger than 2, but this is negative 4. This is to the left of 0. 2 is positive, it's to the right. So 2 is greater than negative 4. Think about this. Would you rather be negative $4 in your bank account? Would you rather owe someone $4? Or would you rather have $2 in your pocket? Okay? Think about that. What about negative 3 and negative 5? Let me do a quick erasing here so we can just focus on this problem. Okay, there we go. Negative 3 and negative 5. Negative 3 is here. Negative 5 is here. Negative 5 is farther to the left. Negative 3 is actually farther on the right. So which one is greater? Well, negative 3 is greater than negative 5. Okay? Think about it this way. Would you rather owe someone $5 or would you rather owe someone $3? It'd be better to only owe them $3 and not have to owe them more money. Okay? What about negative 4 and 0? Well, negative 4 is here. 0 is here. 0 is to the right on the number line. 0 is greater than negative 4, or negative 4 is less than 0. Okay? If you have $0, that's not great, but it sure beats owing someone $4 and being negative $4 in the hole. Okay, now let's talk quickly about ordering integers. Excuse me. I have 4, I have negative 2, I have 1. If I ask you to put those in order from greatest to least, okay, I'm going to first mark them on my number line. So I see 4 is going to be here. I see negative 2 is going to be here. And I see 1 is positive, so it's going to be here. Well, the greatest of all of those is 4. Okay, next one down would be 1. And then the least would be negative 2. Okay, let's do a quick introduction to the coordinate plane. This is what the coordinate plane looks like. I've gone back 6, down 5, positive 6, positive 5. It could be bigger, it could be smaller, but this is what it looks like. It's formed by two number lines on a plane that intersect at right angles. You can see that in the middle, there's 4 right angles there. Okay, you see that. All right. The two number lines are called the axes. Okay, the horizontal axis is called the x-axis. Remember, horizontal, like the horizon. If you're looking out over the horizon and at the sunset, it goes side to side. Vertical is called the y-axis. So this line that goes up and down, y-axis, side to side, is the x-axis. The two axes divide the coordinate plane into 4 quadrants. Okay, the point where the axes intersect is the origin. So the origin is at 0. Okay, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, I know it's kind of backwards, but you start in the upper right, and then you go counterclockwise. So 1, 2, 3, and 4. Okay, we use the coordinate plane to graph. Okay, we're going to graph coordinates. When you graph, first you start going side to side. You go x first, then y. So if I asked you what the coordinates of B is, well, let's see. We go over 1, 2, 3. So we went over 3. So that's our x coordinate, up 2. Okay, you'll notice that both of those were positive. We went over and up on the number line. Okay, if I said, what are the coordinates of G? Well, 1, 2, 3. We've gone 3 to the left, and if you think about it as a number line, that is negative. That would be negative 3. 1, 2, 3. And that's also negative because we went down. Okay, if you're going to the right or up, it's positive. If you're going left or down, it's negative. It's just simply that easy. Okay? Now, if I said, would you please graph negative 4, 3? Well, you would go, or excuse me, negative 3, 4. You would go left 1, 2, 3. Up 4 would be 1, 2, 3, 4. And you would graph the spot right there. If I said graph 5, 2, 1, 2, 3, 4, 5 on the x-axis, 1, 2 on the y-axis. If I said 5, negative 2, Well, 5 is still positive, so 1, 2, 3, 4, 5. But then negative 2, we have to go down. 1, 2. So now we've graphed all of those spots. Okay, quick question for you. Next time I see you, bring an answer. Where do you think we would use coordinates in real life? Give me a real life example of coordinates. Okay, can't wait to see what you come up with. I'll see you then.